Here we go. Today we're going to talk about multiplying polynomials together. Okay. This is a bit different than last time because last time we multiplied monomial times a polynomial, right? Now, instead of monomial, guess what we're going to have? Polynomial times polynomial. So, exactly right. For example, here, I have a binomial times binomial, right? So, x plus 4 times x minus 1 is what we have. And if I want to multiply these two binomials together, first of all, do you think it's a good idea to change everything to addition?
No. Oh, yes.
Yes, it is, because that's how you eliminate some of these silly mistakes that we make. And next, we need to multiply these together. So last time, when we multiplied monomial times binomial, right, we distributed it, right? Claire? Guess what we're going to be doing now? What should we do here, Claire? What do you think? Any idea?
We're going to do x, 2x plus minus 4.
Not quite. What we're going to do is we're going to think of these as, okay, we have two. This is really similar to what we did last time. Last time we had a monomial, right? Now, instead of just one term, how many terms do we have? Two. So we're going to actually still distribute, but this time we're going to distribute how many times? How many terms? Two of these terms instead of one. Do you understand? So basically, you're going to multiply x times first what? X, and then x times -1. Of course, there's addition in between each of these terms, right? And then we're not done because we have one more term to multiply. We're going to multiply 4 times x and 4 times -1. Does that make sense? How many people have seen this before?
Oh, yeah.
There's even a name for this. How many people remember? Yeah. Right. So this method is called. Anybody remember? Yeah.
Is it like Folio?
Yeah, Folio Method. You guys remember that?
Yeah.
So this is kind of like that.
Oh, the front.
Right. Right. But you know that doesn't work for binomial times trinomial. You know, so because you have. So I'm just going to show you. Basically, all you're doing is listen. You're taking the first term and multiplying it with the binomial, and then but you have one more term. You just have to multiply that with the other binomial. Yes.
Last year we did this, but then our teacher taught us like some other way that we could do it, but I forget what that was.
Okay, but let me show you. Let's see if you like this. That's fine. That's fine. But here, so let's multiply this. So first, I even wrote it down. You're going to multiply x times x. So I want you to write it out. Don't just do it in your head. I know that many of you could just do this in your head, but that's where you make silly mistakes. Because as you notice, if you make silly mistake on like one of the exponents or something, right, the whole thing's wrong. You see what I mean? So even though this is not that hard, I want you to write it out. Every time you do these, I want you to write them out, okay? X times x, I'm going to write, guess what? I'm going to write x. No? I'm going to just write x times x like this. Okay? You see what I did? X times x, I get x times x. Just write it out. What comes after? Since if we change everything to addition, what's between each of these terms? What operation is in between each of these terms? Yeah, addition. And then guess what we're going to do next? X times now? -1. So I'm going to actually write that out also. Plus, again, am I done? No, we got to multiply that other term. We got 4 here. 4 times x. I'm going to write out 4 times x. Plus 4 times -1. Now, I want you to then simplify these. Can you do it? Go ahead, everybody try. I'll wait. Finish it up. Shouldn't take too long. So, Christina, tell me what to write here.
2x.
No, x times x is not 2x. It's
Oh, x squared.
that's where people make silly mistakes. Okay, when do you get 2x, class? Lynette, when you add the x's, if it's x plus x, you get 2x, right? But here we're multiplying. Remember, this is x to the first power. X to the first power, you have to add the exponents because you have the same base. Remember? So, Christina, tell me the answer again.
Okay, so x squared
Right.
plus negative x.
Right.
Plus 4x.
Right.
Plus negative 4.
Exactly right. Okay, how many people got this? Raise your hand. Okay, am I done here?
Wait.
No.
Oh, I'm sorry. Here. Am I done here? No. Okay. So then, what should? How about? Let me ask Mimi. What do I do next? Exactly, because these are the like terms. So Matthew, what's the answer? The final answer should be
X squared plus 3x minus 4.
exactly. How many people got x squared? I even wrote this addition. X squared plus 3x minus 4. Easy. Can you do something like this yourself?
Yeah.
Okay, good. So this is sort of things you'll be doing. Of course, are you always going to be multiplying binomial times binomial?
No.
No, of course. It could be binomial times trinomial and something like that, okay? But before I get going, I want to talk about something called standard form. You guys remember we sort of talked about this a little bit because many of you are asking, how should we write this polynomial, right? Do we write x squared plus 3x minus 4, or is it like 4, negative 4 plus 3x plus x squared? How do you write this, right? So we're going to now tell you, we're going to talk about how to write these polynomials in a correct way. Is that okay? So, and again, it's called standard form. So let me move this up a little bit. So write this down. It is often helpful to rearrange the terms of a polynomial so that the degrees of a particular variable are in either increasing or decreasing order. So write this down and I'll show you what I mean by this. But as you write this down, think about what they're talking about, especially where it says degree of a particular variable and where it says increasing or decreasing. Okay. But I highlighted decreasing. Guess what? Guess which method I like better? Increasing or decreasing?
Increasing.
I highlighted the one that says decreasing.
Oh, decreasing.
Yeah, okay. All right, so go ahead, write this down, I'll wait.
Okay.
So, for example, guys, what do you think this means? Let me give you an example here. And again, when you do this, it's called standard form. And I'm going to ask you to write things in standard form when I give you a polynomial, okay? So, for example, here, look at this example, write this down. It says negative 4x plus 2 plus x to the fourth plus 2x to the third. Okay? So it says it is helpful to rearrange the terms so that the polynomial, the degrees of a particular variable are in either increasing or decreasing. And I already said we like decreasing order, okay? So is it wrong to write them in increasing order? No, but we're going to just write them in decreasing order. I'm telling you, okay, it's better, okay, that way. All right, so anybody know how to rewrite them in... First of all, it says rearrange the terms. So terms are separated by which symbol? Addition symbol, addition sign, right? So in this case, do we need to change anything to addition? No, everything is in addition, right? Dana, what do you think I should write this as?
X to the fourth plus 2x minus 4x plus 2.
Yeah, I actually left it as addition, but you're right. Is that okay, guys? Do you see how this is written in decreasing order of the exponents of the variable x?
Yeah.
Right? This is x to the fourth, x to the third, x to the... What power is this? There's nothing there, but this is x to the first, okay? And then plus 2. Plus 2. 2 doesn't have any variables in them, so you just put it at the very end. Is that okay? Yes, sir. Question?
Like,
So if you had like 2 to the 6th power, and you know 6 is higher than all the other one, but you have to choose a variable. Remember, look at what we just wrote down. From a particular variable. So 2 doesn't have any variable in them, so you know what I mean?
yeah.
So that doesn't count. Even if it's 2 to the 6th power,
Yeah.
that doesn't go to first if you're going to write it in decreasing order. You choose a variable,
Yeah.
and from that variable, whatever the exponent
And
is.
second question.
Yes.
What if there's like 2 variables and normally you sort the variables?
Very good. What if there are 2 variables? I'm going to actually, yeah.
You use alphabetical order normally, but
Right.
what if like it's A and B and B's power is higher than A?
Yeah, it doesn't matter. So you still go with A. Yeah, so once you chose a variable, so we'll get there in a minute. Hold on. Okay, any question on this? No? Okay, but for fun, I'm going to write them in increasing order. Is this wrong to write it this way? No. Your book either gives you the answer in decreasing order or increasing order. So I don't want you to think that you did something wrong if they, if you see your answer in, right? If they give you to it in increasing order, it's just still the same thing. Is that okay? As long as each of the terms match up. And of course, you don't write plus negative 4x. You just, at the end, you just write negative 4x, right? Minus 4x, like this, when you write them in decreasing order. Do you understand how to write things in standard form? Okay. What about if I give you something like this? This is sort of along with the line that he's asking. So if I have negative 3x squared y plus x cubed plus 2y cubed plus xy squared. Now we have 2 variables. So which variable should we choose to write this in decreasing order? Yes, sir. X. Why not y?
Because it's because y is farther in the alphabet.
Yeah, we choose these variables in alphabetical order. Does that make sense? But could you choose y if you wanted to? And is it wrong? No, it's fine. It's just this is how we're going to do this, okay? So we're gonna, if there is more than one variable, we're gonna choose the variable that comes first in alphabetical order, which is x here. And don't worry about y at all. You could have y to the 100th power. That's what you're asking, right? It doesn't matter. You just choose one variable, which in case we're gonna choose x here, and then write them in decreasing order. Does that make sense? Go ahead, everybody try. I'll wait. Then who could tell me how to rewrite this in correct standard form? Livy?
X cubed minus 3x squared y.
This is actually plus 3x, you know. I want you to change everything to addition because you could then switch the order around because of the commutative property of addition, remember? Okay, anyway. So yeah, so say it again. X cubed plus
X cubed plus negative 3x squared y
uh-huh.
plus xy squared plus 2y cubed.
Good. Why did you write 2y cubed at the very end? Because there's no x in them, so it goes at the very end. Is that okay, guys? Does that make sense? So we did this in, so we're going to choose one variable whenever there's more than one, right? We chose x in this case. Now, on your homework, right, in the back of the book, they may choose to do it with y. Is that okay? Is that wrong? No. Okay, so if you did it with y, it would be like this. It would be 2y cubed plus xy squared plus negative 3x squared y, parentheses, plus x cubed. Is that okay? Okay, do you understand? So it's okay to write it the other way, but we're just going to use the alphabetical order. Is that okay? So that we at the end we will have the same answer at the very end. Do you see what I mean? It's easier that way. Any question? And there's other advantages of using standard form. Okay, you'll see it in a minute. Okay, may I move on? Okay, good. Okay, let's do example 2. I put a star on this one. It says 2 minus x in parentheses times in parentheses 3 plus 5x minus 4x squared. Okay. So this example 2 looks a little bit different than example 1 because instead of binomial times binomial, we have binomial times trinomial, right? And not only that, look at it. Look at each of these. Look at these polynomials. Are they written in standard form? How many people say yes? Raise your hand. One brave person. How many people say no? Okay, this is written in standard form.
Oh yeah.
Yeah, this is written in increasing order of x. It's okay to do it that way, isn't it? But do I like it that way?
No.
No. So could we rewrite this using decreasing? Okay, could you? And as you rewrite them into decreasing order of the exponents, can you make everything to addition? Right? Can you do that? So tell me what to write, Brianna. What do I write here? If I want to write them in, so we're going to rewrite them in standard form. Okay? Please do that first. It's going to be helpful. You'll see why in a minute. Go ahead, Brianna. What should I write? Good. Negative x plus 2, and then the other one is going to be times. Plus 3 is exactly right. So we're going to rewrite them in standard form. Even though this is in standard form, we like the way that this is written because we like them in decreasing order of the exponents. Is that okay? Are we good? So now I want you to multiply. How many times are you going to multiply this negative x? 3 times, because how many terms do you have? 3. How many times are you going to multiply this 2? 3 times again, because how many terms do you have here? 3. Does that make sense? What if you have 4 terms? How many times would you multiply this negative x by? 4 times, and 2 multiply 2 4 times. Does that make sense? That's how that works. You're going to distribute that each of these terms by how many numbers of terms you have on the other polynomial. You guys get that? Can you do this yourself? Okay. Well, actually, let's do this one together, and then I'll let you do another one. So, Sammy, tell me what to write. When I multiply negative x times the first term of the other polynomial, what do I get? Don't multiply it out. Just tell me what to write. Because I want to see the work.
Okay, so
Negative x times.
negative x times negative 4x.
Good. Plus, what's the next one? Negative x times.
Negative x times 5x.
Good. Plus.
Plus negative x times 3.
Good. How many people could do this in your head? Okay, but do I want you to do that in your head? No, because if you make one silly mistakes here, whole thing's wrong. Does that make sense? Okay, then Song, what do I do next? Am I done? Am I done multiplying these by polynomials? What do I do next? No, I'm not done yet. You can't add them yet. Okay. Samuel? You need to multiply the 2 with the rest of the polynomial. So what do I get now? Plus, again, it's plus again, right? Plus what? 2 times? Song? So look, we just multiply this first term, right, of this binomial with the trinomial here. We're not done. We have to multiply that 2 also. So 2 times what now? 2 times? Good. Don't multiply it yet. Just write it down. 2 times negative 4x squared, then what? Plus? 2 times?
5x.
Good. Plus? 2 times 3. Do you see why I wrote them like not sort of all horizontally, but I wrote them right underneath like this? Anybody see why I did that? Why didn't I just write down next to, write everything horizontally like this? What do you think I wrote them underneath like this? Anybody see why? Dana?
Because when you actually multiply it out, there'll be like the like terms.
Yeah, these are going. The like terms will line up this way. That's why you want to write things in standard form. If you write things in standard form, as you multiply these, like terms will line up. Does that make sense? Of course, you gotta skip the first one because I can see what's x times x. That's x to the second power. What's here? You get x to the second power. You see how they will line up? Do you guys see how I did that?
Yeah.
Do you think that's a good idea? To line them up as you multiply these together? Could you just put them all horizontally? Yeah, it's okay. But aren't you going to gather your like terms anyway? So isn't this sort of nice way to multiply so that the like terms will line up? Do you see how I did this? Okay, so but you gotta skip the first one, okay, and then it will line up. And of course, that only happens if you write things in standard form. Okay, can you then finish up? Okay. Question?
Is this example 3?
Yes. Example 2. Can you finish this up now? Go ahead. I'll give you time. Go ahead. How many of you got for the first term? You got how many of you got this? 4x cubed plus negative 5x squared plus negative 3x. Good. What do we get on the bottom now? Underneath? Samara, what did you get? So what do you get when you multiply 2 times negative 4x squared? You get plus the red one. What do I get on the bottom? Negative 8x squared plus? Plus? Good. And you see how they line up this way? So that they're like terms? Samira, do you see that? Okay. You see this is negative 5x squared. Now underneath you have negative 8x squared. Isn't that nice? The like terms line up this way. So Brandon, what did you get as your answer?
4x cubed minus 13x squared plus 7x plus 6.
Exactly. How many people got this? Raise your hand. Yeah? And of course you can rewrite this as negative 13x squared, right? Using the definition of subtraction at the end. That's what we write. Any question? Again, how many people got this answer? Raise your hand. If you didn't, do you see a mistake?
Yeah.
You do? Okay, fix it now. I'll give you time. Go ahead. If you got example 2, why don't you try example 3 yourself? 2y plus x times xy minus y squared plus 3x squared. Is this written in standard form? This time, no, it isn't. So you have to actually write them in standard form. Whereas the other one, you could have just done it that way. But it's best to write them in decreasing order anyway, right? So go ahead, everybody, write this in standard form and see if you can get the right answer. Okay, go ahead, I'll wait. And do you think it's a good idea to change everything to addition?
Yeah.
Yes, okay, good. Go ahead, everybody try. So, how many people wrote the a problem like this in standard form? X plus 2y times 3x squared plus xy plus negative y squared. Raise your hand. Good. Okay, so somebody tell me what to write. It's going to be x times, yes, Jason?
X times 3x squared plus x times xy
Good.
plus x times negative y squared.
Good, that's what I got. And what do we get underneath? How about Patty?
2y
Plus, right? Everything's plus, right? Everything's addition. Yeah, plus what? 2y.
plus 2y times 3x squared
Uh-huh.
plus 2y times xy
Good.
plus 2y times negative y squared.
Good. Did you guys put this step? Guys, I'm telling you, this is the critical step. How many people put this down and got it? Okay? Because this is where people make silly mistake if you don't do it this way. People try to do this in their head and get it wrong. So then when you multiply this out, did you guys get 3x cubed plus xy? 3x cubed plus x squared y plus negative xy squared, right? And underneath, you see how the things will line up? You get 6x squared y plus 2xy squared plus negative 2y cubed. Isn't this nice? Right? All the like terms line up. Look at your work. If you didn't get this, that means you're not going to get the right answer. You got this? Carolyn, what did you get as your answer then?
I got 3x cubed
Yeah.
plus 7x squared y
Good.
plus xy squared
Good.
minus 2y cubed.
Good. That's the right answer.
I did the same thing, but I didn't like get what you were saying to put it under.
Okay, if you forgot to, but do you see how it's nice to put it right underneath where the like term will match up? Yeah. Okay, go ahead and take a look at it. Any questions? So example 4 says they give you this picture. By the way, how do you find an area of a rectangle? Length times width. So the question is this. Find the sum of the areas of the 4 smaller rectangles. And of course, we know we start with the formula. Area is equal to length times width. Do you see how these we have 4 small areas, area A, B, C, and D? Okay, can you guys find the area of A, B, C, and D and add them together? Because they tell us to find the sum. Can you do something like this?
Yeah.
Go ahead, everybody try. I'll wait. Somebody tell me the area of A. Chuck?
X squared
X squared, how'd you know that?
is x times x.
Yeah, length times width, x times x. This is square, isn't it? Okay. Somebody tell me the area of B. This is pretty straightforward. Matthew? 5x. How'd you know that? Yeah, it's because the width is 5, the length is x, right? It's 5x. Somebody tell me the area for C area here. Michael? 3x. How'd you know that? It's 3 times x, right? How do you find D? Because it doesn't tell you anything about the side. Christina, do you know how do you find the area of D?
3 times.
Yeah, it's 3 times 5. How'd you know? It doesn't say anything.
Oh, because 5.
Yeah, it's on the top, right? If this is 5 up here, isn't this 5 down here also? Right? If this is 3 on the left, isn't this also 3? So how many people got this? Okay, now, am I done?
No.
They told us to find the
Sum.
sum. What does it mean?
Addition.
You add them together. So, Song, what you get?
X squared
Uh-huh.
times 10x.
No, you don't you're finding the sum, so you have to add them all together. So you add x squared plus,
So that's 15x.
yeah, 15x. So you just add them together. You find the area of A. We found four areas, right? Just tell me what you write. You go x squared plus 5x plus what? 3x plus
5x. So what?
15. We were adding A, B, C, D right here. Okay? So am I done?
No.
What do I write? Don't you have like terms? So what should your answer be?
X squared plus 8x plus 15.
Exactly. How many people got x squared plus 8x plus 15? Okay, so good. What kind of question do you have? I am actually anticipating a question. What question? Let me see if you're thinking what I'm thinking.
Can you do it just because the sum is basically the area of the whole rectangle? Can you just do x plus 5 times x plus 3?
Did you hear what you just said? Guess what? Do you see this is part A? Okay, some of you are asking, wait a minute. Couldn't we just do this so that, Algebra, you read my mind. So couldn't we just do it this way? We knew that this was x. What's the whole width then? If this is x, this is 5. What's the whole width? X plus 5. What's the whole length? If this is x, this is 3 right here. Couldn't we then just do this by, instead of figuring out all these 4 parts, couldn't we just do it by what? Area is equal to? Yeah, x times x plus 3 times x plus 5. Do you think we should get the same answer as before?
Yeah.
Go ahead, everybody try. Let's see whether we do that. Okay. It's very good, very good. That's what you could do. And do you see why we're learning, right? If you didn't know how to multiply by polynomials times polynomials, you wouldn't be able to do this, right? Go ahead, everybody try. Because your end result is the same, isn't it? Go ahead, everybody try. Here we go. So how many people got x plus 3 times x plus 5? You distribute it like this. You get x squared, right? Plus 5x. And then 3 times x is what? What's 3 times x, class? 3x. And 3 times 5 is, which is?
5x.
What?
What?
No. Okay. Right, okay. X times x, you get x squared. X times 5, you get 5x. Then here, 3 times x, you get 3x. And then, of course, you got to do 3 times 5, which is plus 15. What's the answer? X squared plus 8x plus 15. Is this what we had before? Yeah, it's the same, exactly. The same thing. Right? So even if you separate them into 4 right? Areas of 4 of these pieces, or just get the whole thing together. The area is the same, right? No matter how you do it. Does that make sense? Any question? Easy? Okay, good.